by,
It's reciprocal.
yep. So that becomes meters times seconds over meters. Meters cancel out, you're left with seconds. It is division. You could also look at it this way. If you think about the units here, I know that the units of speed or velocity is meters per second. Well, that's a unit of distance over units of time, so that would be a unit of distance over a unit of time. And so average speed is just distance over time. And then if I have two fractions equal to each other, I can just move stuff across the diagonal without any problem. So I can just flip those two, and so my time is distance over v. Yet a different way of looking at the exact same thing. So anyway, distance over speed. So we have 10 centimeters, or 0.1 meters. So time would be 0.1 meters divided by my speed, my average speed, 14.745. Whatever that is. What's it 0.07-ish? 0.0. Yeah, somewhere around 0.07 seconds. Someone's going to tell me a more exact value in just a moment.
You want somebody to tell you a more exact?
I would.
Okay, I can't read 14 point what?
745, that number right there.
It's 0.0067. Well, you can do
Okay,
6,
yeah,
8,
I see where my mistake, should be another zero in there.
You can do 6, 8, really.
6, 8, okay.
Yeah.
All right. Thank you. So I now know the time, and it's left with just finding the acceleration. And I believe vector acceleration, or they do acceleration with a with a vector symbol over it. Okay, so I'm looking for a vector here. Well, what's the formula for acceleration?
Velocity over time.
Close.
Final velocity minus initial velocity over time.
That works. Or for change in velocity. So acceleration is change in velocity over time, which is final velocity minus initial velocity divided by time, which is 0 minus 29.49 divided by, we just came up with a time of 0.0068. That's meters per second on top and seconds on the bottom. And we get a final answer of around 4,400. And I assume you've got a number.
Yeah, but I don't think it's right. Negative 4,000.
Negative 4,376.
36.
4336.
0.76.
I think the number's in the ballpark. Anyone else got the same thing?
Yeah.
Okay, a number of people. Just they're afraid to go first. All right, and units?
Meters per second squared.
Done.
Question, does it ever matter, like, or do we ever have to specify when we estimate it, or no? Like, would you want to know?
Do you need to specify what you estimated? Give me a situation. I mean, like when I was making numbers up?
Well, I mean, cause I usually estimate, and you said it's really not a problem, but I mean, I can't really get in a situation where I can.
I'm assuming that you have a calculator, so there's no need to estimate.
No, I'm saying like in a situation where I wouldn't test it, or if I'm like, if I do have numbers that you gave to us or whatever. Like, I estimate those. And then like to the property, just regular, like, but estimate.
Now, when you're saying estimate, let's make sure we're in the same language here. Estimation is, for instance, I did 29.49 divided by 0.0068 in my head by multiplying roughly 30 times 15 and then dividing by something. Are you talking about rounding?
Yeah.
Okay, oh, so rounding. So the 29.49, for example, if you had just written down 29, that's probably fine. I would then base the rest of your answers on that. So, yeah, you can round there. You know, there's sort of a, how much are you allowed to round? If in doubt, 3 non-zero digits, but it, you know, depends on the case. I'm on a lab, I'm pickier than on a test. Because assuming in the lab you have more time to think through it. I don't know if I answered your question or not.
Thank you.
Which says, I've given you an answer,
Sorry.
whether it's a good one or not, isn't,
It works.
let the historians decide. Or all those international fans who no doubt will be flocking to my videos. Other questions? Other questions on this?
Yeah.
Okay, kind of.
So the time for it to stop, the formula is different distance over average velocity?
Would be time, yes.
Okay.
That, going back to something I had written down earlier, is that displacement is equal to average velocity times time. And so to find time, you just divide by, get rid of that by bringing this over. Now, I've gotten really picky in the past about distance versus displacement. One is a scalar and one is a vector. If it's only going in one direction, you can get away with the sloppiness in the language like I was doing. If it changes direction, whether it's curve or just doubles back on itself, then distance and displacement become very distinct. But in this, it's only going in one direction, and so the distance it traveled is a certain amount in one direction, and then the displacement would be whatever that is with some way of signifying the direction. In this case, down is positive, so the displacement was 10 centimeters down, the distance traveled was 10 centimeters. Right. Other questions? Whether about this or another question? 14?
That's correct.
Describe the motion. Yep. Anybody need any of this still up before I erase it?
Yeah.
Paparazzi are done. And in theory, it is being filmed, assuming that it's still going.
Yep.
So this is position versus time. And I know this is not part A, this I'm leading up to it. So if that's position versus time, what is an object doing in that situation?
Speeding up.
Sorry. I've heard 3 people answer and I still couldn't understand any of it.
Moving up.
Not necessarily up.
Moving fast.
I haven't given numbers to know that.
Steady rate.
Constant rate.
Okay, I'll buy that one.
Moving away from the origin. Moving away from the origin.
Okay, I'll agree with that. We can be more specific.
Moving away from the origin, at a constant speed, well, at an increasing speed.
No, it would be constant.
Constant, okay. Because it's a straight line.
Now, why did you say up? Just because the line's going up? Yeah, but that could be representing an object that's moving.
Over time. Over time, is that what you're?
Well, definitely over time, because time's in there, but
In a positive?
there we go.
Positive.
Not necessarily up, but it's moving in a positive direction, because we are sticking with the standard that wherever my horizontal axis is, above that's positive and below that's negative. So, I'll just go ahead and write down what we basically came up to in the end. Object moves at constant velocity in positive direction. All right, so let's concentrate on just the constant velocity piece of it. What is velocity anyway?
Displacement over time.
Okay, what else?
How fast and in what direction?
Okay. Presumably it's in a video somewhere, but when you are driving, and let's just simplify matters, automatic transmission. If you are driving, what are the 3 accelerators you have direct access to as a driver?
Pedal?
Pardon?
The gas pedal?
There's 1,
Brake
that's 2,
and a steering wheel.
yep, and that's 3. The last one being dealing with the change in direction. So how do we know that this velocity is constant?
It's a straight line. It's not bending, I guess.
Typically it's at curved, but yeah, bendy works. Yeah, because the slope of this position versus time is velocity. Straight lines have a constant slope. So if the slope is constant, the velocity is constant. Questions before we make it more difficult, or make it look more difficult? All right, suppose that's my position versus time graph there. What can we conclude about that?
The slope is not constant.
Okay, therefore,
The velocity is not constant.
okay, that is true. What else?
It's increasing.
Increasing what?
Speed.
Speed and position.
Yes, both. The reason why I said, I'm not quite sure what the intent was. It is this increasing position. This is known as an increasing function because as you go from left to right, it's going up. But velocity is also increasing. So how do we know velocity is increasing?
Because it's going positive direction.
Say it again?
Because it's in a positive direction.
That doesn't tell me the velocity is increasing. That tells me the position is increasing. How do we know the velocity is increasing?
Is it something to do with the slope?
It has something to, yes.
It's curved up.
Yes. So if you have a curve and you're trying to figure out what is the velocity there, what you basically are doing is, the velocity is not constant, so you have to really determine what's the velocity at some particular spot. So if I want to know the velocity at that spot right there, I have to sort of create a line, a straight line. You, in essence, draw a tangent line here. So that, the slope of that tangent line is the velocity at that particular moment in time. And then I go here, and I can draw a tangent line there. So I have two lines here, which has a steeper slope. We'll call it first one, second one.
Second one.
Yeah. If you came across a mountain like that, you'd say that's definitely steeper than one that's like this. So the slope increases here because the tangent lines get steeper and steeper. So this is object moving in positive direction. With increasing velocity. Or you could get, it's only traveling in one direction, increasing speed also works. I guess I've already identified direction there, so with increasing speed.
So whatever there's a curve is always gonna be increasing velocity.
Or decreasing, right?
It's changing velocity. So what would it look like if, what would my position time graph look like if I were decreasing speed while traveling in the positive direction?
It's like,
Possibly, you were doing this, that,
To the other side.
that,
Oh, that's increasing, right?
Oh.
what's increasing?
The velocity is increasing to the point like
The velocity is decreasing here
that. Oh.
because my slope starts out steep and becomes less steep as I go. What is increasing?
The acceleration.
Sorry, say it again?
The acceleration.
No, not acceleration.
The position.
displacement.
Yes, or position, either one in this case. Lydia, you have your hand up?
So wouldn't you have to start from like a higher place of displacement and then gradually?
I mean, like that or like that?
Well, would it be a constant, decrease, so it would be just a straight line? No.
So you're picturing that?
Yes.
All right, so what's going on? Actually, these three have something in common. Luis, what was that?
They're all decreasing.
They're all decreasing. What's decreasing?
They're going down.
They're all negative.
What's negative?
The velocity.
Okay, velocity is negative. So which way is this thing traveling in these three cases?
Down.
Towards.
Negative direction.
Yes. Not necessarily down, just in the negative direction, whatever it happens to be for that context. So these are all traveling in the negative direction, those are all traveling in the positive direction. So now let's look at, so these are all travel in negative direction. The velocity is negative because the slope is negative in all three of those cases. So velocity is negative, which means you're traveling in the negative direction. So, in one of these cases, we'll just call this 1, 2, and 3. In one of these cases, the object's moving in the negative direction at a constant rate. In one of these cases, it's speeding up as it travels in the negative direction.
3.
It's 2 or 3, it's one of those two.
3.
You speaking with confidence?
Yes.
Okay. Because you should. Why do you say this one is speeding up in the negative direction?
Well, I'm just thinking of like, you know, the boy that was falling in the air and it gets faster as it descends.
Ah, okay, that works.
Isn't the slope for number 2, like, with the thing you did there, it's steeper on the
Keep going.
position side than on the time side, so
Oh.
it's steeper, no. For that dot, it would be steeper than that dot. Like if we
Yeah,
put this dot
okay.
on the left, kind of the top middle, as opposed to it, no, the number 2,
Okay, so it is steeper here
yes.
than it is here. So it's slowing down. That's what you were getting towards? Or you were just,
I don't know, I lost it, sorry.
it is steeper here than it is here.
Okay.
Because a horizontal line, if I have a position versus time, horizontal line means, let's go ahead and do that one. Position, time.
It's not moving.
Right, exactly. So the closer it gets to horizontal, the slower it's going, the closer it's getting to not moving. So here it's not moving at the end, as time progresses left to right. Here, it's not moving very fast at the beginning, because it starts out rather horizontal and then gets steeper and steeper.